Okay, so talk about the accommodation and convergence. So what is the accommodation and convergence, and what are the relations? So when you are looking to a far target, where both visual axes will be aligned parallel, but when you are looking to a near target, what happens? What happens is what's called the near reflex. And the near reflex consists of three constituents. First of all, there will be that the lens here will be bulging and the lens will increase in size. So there will be what's called accommodation. The second thing, just hold on. The second thing is that the pupil size will become smaller, and this is what will be called meiosis, to increase the depth of field and depth of focus. And finally, there will be turning inside of both eyes, which was called convergence. So this is called the near triad. Near triad is convergence, meiosis, and accommodation. So is there any relation that will govern the accommodation and convergence? The answer is yes, and this is what will be discussed in this section. The accommodation can be divided into absolute accommodation and relative accommodation, and the relative accommodation itself can be further subdivided into positive relative accommodation and the negative relative accommodation. The same thing applies for convergence. So there is absolute convergence and relative convergence, and the relative convergence is further subdivided into positive and negative relative convergence. So what our aim here in this lecture is to study what's called the amplitude, the near point, the far point, and the difference between both of them will be called the range, and the accommodation to convergence ratio. So we need to know the amplitude of accommodation and the amplitude of convergence. What are they? The near point of accommodation and the convergence, the far point of accommodation and the convergence, and what is the difference in range between them, and what is the relation that will govern or what is the equation that will govern the relation between the accommodation to the convergence. So what is the accommodation? Accommodation is a mechanism in which the lens increases its power by bulging or by anatomical configuration. So the lens will change its shape in order to increase its power. And this accommodation occurs when the ciliary muscle contracts. So when the ciliary muscle contracts, this will lead to relaxation of the zonule, or what's called slackening of the zonule, leading to bulge of the lens and leading to increase of the anteroposterior diameter of the lens, so that this will lead to increasing the power of the lens and increasing the power of the eye, so that the eye will now become more powerful and bring can see the near targets and can bring the focus on the retina. So let's say, for example, the patient is now looking at a near target, and then the image of this target is located behind the retina. So now this eye is hyperopic for this target. So what happens is that the lens increase its power and increase its the ciliary muscle will contract, leading to relaxation of the zonule, causing that the lens will increase its power so that it can see this this near target. So we know that there is a relation, or the rule number one in optics is that the power equal 1 divided over the focal length. So this can be used to know what is the needed power for accommodation in order to see the near target at a specific distance. For example, if we have a near target like this book at a distance of 1 meter, this means that the power is 1 meter, so that the 1 over focal length, then the focal length will be equal. If the focal length is 1 meter, then the power of accommodation needed to see this book will be equal 1 diopter. If the book is moved to 0.5 meter, then the power of the needed diopteric accommodation will be 2 diopters. If again the book is moved to 25 centimeters, then the power of accommodation needed will be about 4 diopters. If it is moved closer and closer to the eye, like about 10 centimeters, then the power of accommodation needed will be 10 diopters. So the power of accommodation can be measured by this equation. There is two concepts that we discussed before that are called the punctum proximum and the punctum remotum. So the punctum proximum, which is the near point of accommodation, meaning that it is the nearest point of an object that it can be seen clearly without blaring while the accommodation is at maximum. So if we approximate a near target to the eye, so that the eye will start to accommodate until a certain point at which the eye exerts its maximum accommodation, and further movement of the target towards the eye will cause blaring, then this point will be called the punctum proximum, or near point of accommodation. The punctum remotum will be the reverse. So if it is if we make a distant target at which the patient can look with and the image can fall on the retina and they can be seen clearly while the accommodation is completely at rest, then this image is, or this point is called the punctum remotum, or the far point of accommodation. So punctum proximum, it is the nearest point with full accommodation. Punctum remotum, it is the farthest point with the accommodation fully relaxed. So for example, if we say that the patient is immetrope, so the patient is immetrope, and then this patient has a punctum remotum at infinity, as we mentioned before. So the patient has punctum remotum at the infinity, and the accommodation will be equal 0, because the patient in the punctum remotum is the point at which the accommodation is completely relaxed. So accommodation will be equal 0. So what happened if we approximate the book until the patient now exerting accommodation, until the patient exerts the maximum accommodation, and at this point, if any further movement of the book toward the eye will cause blurring of vision. So this is called the punctum proximum. And if this punctum proximum is about 25 centimeters, so by knowing that the point of punctum proximum, we can know the power of accommodation of the patient. So the patient has an accommodation of about 4 diopters. So the amplitude of accommodation, meaning that it is the difference in the diopteric power between the eye at complete rest and the maximum accommodation. So here, while the patient is looking at the infinity, so that the accommodation was 0, and while the patient was looking at the punctum proximum, the accommodation was 4. So the difference between both of them, this is the amplitude of accommodation. So here in this example, the amplitude of accommodation is 4 diopters. While the range of accommodation is the difference in distance between the punctum remotum and the punctum proximum. So the punctum remotum will be at this example at the infinity, and the punctum proximum will be at 25 centimeters. So the difference between them is called the range of accommodation. So the amplitude of accommodation is this value in diopters, but the range of accommodation, this is the value in distance. Between when the eye exerts the maximum accommodation and when the eye is completely at rest with no accommodation at all. So in order to calculate the amount or the amplitude of accommodation, we need to know what is the refractive power of the eye for the punctum proximum, and subtract from it the refractive power of the eye for the punctum remotum. So if we know how much the power is how much is the total refractive power while it is looking at the near target, at maximum looking at near target, and subtract from it the power of the eye while it is at rest, so there is no accommodation at all, we now can know the amplitude of accommodation. So how much this occur, or how much this will be in the case of emmetropia? So in emmetropia, we know that the power of the punctum remotum, or the power of the eye, the punctum remotum will be 0, as there will be no accommodation while the patient is looking at infinity. So A will equal P. So the amount or the amplitude of accommodation will be equal the amount of accommodation while the patient is looking at the near target and the punctum proximum. So is this accommodation a fixed number or a variable number? It will be a variable number, as we mentioned earlier before, again and again. We are born with large amount of accommodation to compensate for the very short axial length as we are newborn. And as we get older, the eye elongate, so that this will be compensated by decreasing of accommodation. So as we get older, there will be gradual decrease of amount of accommodation, so it reach about 4 diopters at 40 years old, and this is when the complaints start of presbyopia. And at age of 60, we have barely 1 diopter of accommodation. So how can we measure the accommodation? There are some methods for objective measurement and subjective measurements. Objective measurements will be discussed thoroughly in the instruments lectures. So we have retinoscopy that can be used for both measuring the punctum remotum in bistatic retinoscopy, which is more commonly used, and we have dynamic retinoscopy for measuring the punctum proximum. And this is and there is another method is called the autorefractometer that can be also measuring the amount of accommodation. We have also subjective methods, so we can use subjective method to determine punctum proximum and the punctum remotum, and with the difference between them, we can calculate the amount of accommodation by subtracting the power of the eye as the eye at punctum proximum minus the power of the eye as the eye at the punctum remotum. And this can be done by a ruler called the accommodation rule. So this is a rule that has a moving target that can move along this rule, and then we approximate it to the patient and seeing what is the maximum best corrected visual acuity as we approximate this car towards the patient. So the best corrected visual acuity as we approximate the card toward the patient, this will be the punctum proximum, and as we move it away from the patient, we can also calculate the best corrected visual acuity as the patient is looking to the far, which will be the far or punctum remotum, and subtract the distance between both of them, so that we can reach and we can know the diopteric value of punctum remotum and the punctum proximum, so that we can know the difference or the amplitude of accommodation. Here we come to some other concepts regarding the accommodation. So we have the absolute accommodation and relative accommodation. So what is meant by absolute accommodation? Absolute accommodation meaning that it is the amount of accommodation needed to see a clear image of an object at a given distance. For example, you can, if you need about 4 diopters or 5 diopters or 6 diopters to see an image of an object clearly, then this is called the absolute accommodation. On the other hand, the relative accommodation will be the relative to something, which will be relative to convergence, meaning that how much you exert accommodation or relax accommodation with a given constant amount of convergence, meaning that if a patient have about 20 prism diopter of convergence, how much the accommodation is exerted or how much the accommodation is relaxed. And this can be further subdivided into positive and negative. So what is positive relative accommodation and what is relative negative accommodation? Positive relative accommodation meaning that it is the amount of accommodation exerted with a certain given amount of convergence, while negative meaning that it is the certain amount of accommodation relaxed with a given amount of convergence. So can this be measured? The answer is yes. The positive relative accommodation can be measured, and the negative relative accommodation can be measured using the lenses. So how can this be done? Let's see. If we have here now at a certain amount of convergence. So this eye converge and this eye converge at this book at a certain amount. So I need this lens is contracted by a certain amount. So now I need to know what are these terms. So absolute accommodation at a given distance, like this, for example, what is the amount of accommodation exerted? Let's say, for example, it is 4 diopters. While relative accommodation, I wanted to know what is the accommodation in relation to this convergence, in relation to this about 20 prism diopter convergence. So this can be divided into positive or negative. So positive meaning that as this condition, this is accommodation exerted. So now the ciliary muscles are contracted and the lens is bulging. So there is an exertion of accommodation. So how can I measure that this number of accommodation? And what is the negative? If we place this book away from the eye, so the eye is now relaxed and there is no contraction of the ciliary muscle and there is no contraction of the lens. So now the accommodation is relaxed. So if we have a certain convergence and there is no exertion of accommodation, how much the accommodation is relaxed? This is called the negative convergence. So how can we measure each of them? The positive relative convergence can be measured by the highest minus lens. Let's say, for example, then this eye is converging and at 20 prism diopters and having a lens that is exerting accommodation of about +4 diopters. So if I put minus lens of -1 and then -2 and then -3, and then the eye still can overcome this, and -4, and then the eye cannot see any clear image of the book, then this is called the highest minus lens that will equalize the positive relative convergence. So the highest minus lens can be used to know what is the value of the negative of the positive relative convergence. The reverse will occur in case of the negative relative convergence. So if the myopia or if the accommodation is relaxed, then we need to stimulate it by the highest plus lens. So if the accommodation is completely relaxed and now we put high plus lens in front of the eye so that it will blur the image of the distant target as the accommodation is relaxed, and the eye cannot overcome this highest plus lens, then this can be a measure for the negative relative convergence. So if the patient can tolerate the highest minus lens or the highest plus lens without diplopia, then this is mean that this is the amount of relative positive and relative negative convergence. Sorry, negative relative positive and relative negative accommodation. So it is relative to the convergence. Okay, so the same thing occur, or the same concepts will be repeated for the convergence. So what is the convergence? The convergence is the process by which the visual axes are turned inward to the object of interest. So here is the eyes are looking to the far target, and here are the eyes are looking to a near target, exerting a convergence in order to see this near target. So the convergence will be apart from the near reflex triad. So again, if the book is here at 1 meter, so the eyes are looking forward, straight forward. But when the book is approximated at about 0.5 meters, then the eyes will slightly converge. And when the eye is approximated more and more, the eyes are converging more and more. So the convergence also increase with the with decreasing the distance between the near target and the eye. So this can lead to what's called the near point of convergence and the far point of convergence. So the near point of convergence, meaning that it is the nearest point of an object that can be seen clearly without diplopia, while the convergence is maximum. So you need to, if you want to test it like now, just to put your index finger in front of your eyes and slowly approximate it toward your eyes until you see it double. So the area or the moment just before you see it double, is what's called the near point of convergence. Theoretically, it will be the same if you are placing your finger or you're placing a target away from the eye. So when you are placing a target away from the eye should be theoretically, or they should show slight divergence or slight deviation. So the far point of convergence is the point at which the objects are placed in which the eye is completely at rest. So it will be slightly divergent. So let's say, for example, here we have the eyes looking at the book at the infinity. So here the eye are ortho, or they are slightly divergent because the book is placed at the infinity. So this will be the far point of convergence. When we approximate the book, both eyes converge. So when the eyes converge at 25 centimeter and the further convergence of eyes will cause diplopia, then this will be called the near point of accommodation. The difference between the convergence from the near point and the far point will be called the amplitude of convergence. So the amplitude of convergence is the difference in power of convergence required to maintain the eye at near and far point of the convergence. And as you may expect now, the range of convergence will be the distance between the near and far point of convergence. So this will be just the same like accommodation, just remove accommodation and put convergence, and it will be the same thing. It had the same terms, so we have absolute convergence and relative convergence. What is absolute convergence? It is the amount of convergence needed to see the object clearly at the given distance. So for example, if we have an object at about 50 centimeters and we need to do 20 prism diopters of convergence in order to see it clearly, so this is called absolute convergence. Relative convergence, meaning that in relation to accommodation. So it is the amount of convergence that can be exerted or relaxed in relation to a given amount of accommodation. So this can also be further subdivided into positive and negative. So the positive is the amount of convergence exerted with a given constant amount of accommodation. And the negative will be the amount of convergence relaxed with a given constant amount of accommodation. So again, let's see for this example. Let's see, for example, that this book at about 25 centimeters and we need the lens will exert 4 diopters of accommodation. So we have a fixed amount of accommodation and we need to know what is the amount of convergence, relative convergence, either exerted or relaxed. So for this example, the eye is converging in order to see the book. So if we want an absolute value, this will be a given distance. You just mention the distance and we need to know what is the convergence at this distance. But if we have a lens power or a lens an accommodation, then this is called a relative convergence. We need to compare the convergence to the amount of accommodation. And in such a condition, this is called a positive convergence, because the eyes are the lens are exerting accommodation and the eye are turning inward, so there will be a convergence exerted in relation to the accommodation exerted. On the other hand, if the book is located away from the eye so that the relation is relaxed, so it will be a negative convergence because the convergence are relaxed and the eye are slightly divergent. So the difference between the convergence and the accommodation comes to this point, because if we are measuring the accommodation by the highest plus and the highest minus lens, this can't be the case in case of convergence. But we measure the convergence by the prism. So the positive convergence can be measured by the strongest prism base out, while the negative convergence can be measured by the strongest prism base in, that the patient can tolerate without diplopia placed in front of one eye. To explain this, imagine that this patient has now a base out prism. What will happen if the patient has base out prism? Then This will result in exerting more convergence because the light rays will deviate toward the base while the image and the eye will deviate toward the apex. So the eyes will turn inside in more. And this, if the patient has the highest amount of relative positive convergence, then this will result in diplopia. So the strongest prism base out will be a measure for the positive relative convergence, because this base out prism will cause more convergence, so this will leading to diplopia. The reverse will occur if in case of the negative relative convergence. So in negative relative convergence, which will be the relaxed convergence, this will lead to this eyes should be divergent. And if we place a prism base in the eyes, this prism base in will cause the eyes to be more divergent. And if the eyes has the maximum relative negative convergence, then the eye will not tolerate this more deviation, so that it will cause more diplopia. So to summarize, if the positive relative convergence is the strongest base out prism placed in front of the patient eye without diplopia, while the negative relative convergence will be the strongest base in prism that can be placed in front of one eye without suffering from any diplopia. Finally, we have a relation that will control both accommodation to convergence, which is called accommodation convergence over the accommodation ratio. So for every amount of accommodation, or every unit of accommodation, there is a certain amount of convergence that we normally exert. And this ratio is governed by, and this ratio is called or this ratio is about 3:1 or 2:5:1. So for each one diopter of accommodation, there will be 3 to 5 prism diopter of convergence. So this is in normal individuals. Sometimes there are some individuals with higher than normal or lower than normal. So how can we measure this ratio, or how can we measure the accommodation convergence to accommodation ratio in order to know what is the relation of convergence to accommodation? First, we do a prism cover test at 6 meters and then at 33 centimeters to know the power of the eye, the total power of the eye at the near point of accommodation and at the far point of accommodation, so that the difference between them will be the amplitude of accommodation. In order to calculate the accommodation to convergence divided over the accommodation ratio, this will be the difference in this dioptric power over 3. So again, the difference, or the accommodation convergence over the accommodation ratio, will be the difference in the dioptric power between the patient when he is looking to the far and the patient who is looking to the near, and this can be measured in the diopters, divided over 3. So if it is 3:1 or 5:1, 2:5:1, this is normal. If it is more than this, then this patient has high ACA ratio. If it is lower than this, then the patient has low ACA ratio. So this is the meaning that this is the accommodative power required to focus at the 33 centimeters. So this is the significance of ACA ratio. It is the accommodative power required to focus at 33 centimeters. So this is the end of this lecture. Do you have any question in the accommodation or convergence?